The universe has a direction, not in space, but in time. And everything, from melting ice to dying stars, follows it. Stars are born from clouds of dust, gathering into brilliant points of light. Galaxies turn slowly through the dark, carrying the imprint of an earlier, more ordered universe. But beneath all of it, something subtle is happening, a quiet tendency, a steady drift from order toward disorder. Physicists call this the arrow of time, not a physical arrow in space, but a built-in asymmetry woven into the fabric of reality. It shapes every transformation in the universe. From the smallest systems to the largest structures, we observe its effects in the simplest of occurrences, often without conscious thought. Over time, organized systems become less organized. Structure gives way to dispersion. Energy spreads out. This quiet tendency toward disorder is known as entropy, and it's what gives time its direction. We see it everywhere. Smoke spreads into the air. Sand structures collapse back into grains. Heat flows outward until differences fade. These changes all move the same way, toward greater disorder, never spontaneously back toward perfect order. This one-way drift toward disorder doesn't just shape the universe, it shapes how we experience time itself. Memories point backward, never forward. A shattered glass does not spontaneously rebuild. Raindrops do not rise from the ground and return to the clouds. Because entropy increases, the past contains more structure than the future. That difference is what memory depends on. Memory is not abstract, it's physical. Every memory requires a record, a pattern stored in neurons, a trace left behind in the world. And creating those records increases entropy. When light reflects off an object and enters your eyes, when signals fire in your brain, when information is stored, energy spreads, heat dissipates, disorder increases. The past leaves records. The future has not yet done so. That's why we remember yesterday, but not tomorrow. But this raises a deeper question. If entropy always increases, why was the universe ever ordered enough for time to have a direction at all? To understand the arrow of time, we have to go back to the beginning. The early universe was not chaotic. It was extraordinarily smooth. Matter and energy were spread out with almost perfect uniformity. In thermodynamic terms, it began in a state of remarkably low entropy. That low entropy beginning created a gradient, a difference between past and future. As the universe expanded, structure formed, stars ignited, galaxies emerged, and with every new structure, entropy had somewhere to go. Ever since that moment, the universe has been moving toward higher entropy. That ongoing increase is what gives time its direction. Ever since that low entropy beginning, the universe has been unfolding in one direction, from order to disorder, from past to future. Every star that ignites, every atom that rearranges, every memory that forms, traces that same irreversible path. We are part of that unfolding, temporary structures in a universe gradually dispersing, carrying records of what has been, but never of what will be. Time does not move forward because it must. It moves forward because entropy does. And somewhere within that cosmic drift toward disorder, we became aware of it. The universe became ordered enough, in some regions, for awareness to arise and notice the arrow of time at all. A brief pocket of order, looking back toward the beginning and forward into uncertainty.